In this class, we are going to solve 11 different examples, and the first one says, a metal rod with heat capacity 600 joules per Kelvin is heated until its temperature changes from 40 degrees Celsius to 80 degrees Celsius. Calculate the quantity of heat supplied to the rod. The options: 12 kilojoules, B 18 kilojoules, C 24 kilojoules, and D 36 kilojoules. Looking at the quantities given, we are being given heat capacity and differences in temperature. This temperature is in degrees Celsius, but the heat capacity is in joules per Kelvin. So we are going to convert from degrees Celsius to Kelvin, although the differences will still be the same. So let's proceed. Solution: the heat capacity is given. Then we have converted the theta to second temperature from 80 degrees Celsius. We add 273 and it gives us an equivalent value in Kelvin. We also convert the 40 degrees Celsius to Kelvin. The difference is obtained, which is 40 Kelvin. We have picked our expression Q equals to C change in theta, where the C represents the heat capacity. So we are going to substitute the values we have into the expression. So the heat capacity 600 and then the change in theta 40. When we multiply, we get the product, which is 24,000 joules. But if you check the options, it was in kilojoules. You now see that option C is suitable because kilo here represents 1000. So the correct answer is the option C. Let's go to the next question. The quantity of heat required to change the unit mass of a substance from its liquid state at boiling point to vapor without a change in temperature is latent heat of vaporization. The amount of heat required to change the state of a solid to liquid state at a constant temperature is latent heat of fusion. This one says, estimate the heat required to melt 2 kilograms of ice at 0 degrees Celsius to water at 0 degrees Celsius if the latent heat of ice is 336,000 joules per kilogram. Okay, so we are to estimate the heat, and we are being given the mass of ice to be 2 kilograms and the latent heat of fusion of ice to be 336,000. Alright, so let's continue. We pick an expression Q equals to ml, where m is the mass of the body and Lf is the latent heat of melting. When we substitute the value for the mass and the latent heat, we obtain 2 times 336,000. The product gives us 672,000 joules. but we don't find this in the option, so we have to check our convention and standard form very well. Looking at this one here, we see kilo. Kilo stands for 1000, and we also see this one has an index of 2, of which if we add the 2 will give us an equivalent value to this 1, 2, 3, 4, 5. Okay, so the correct option is option B. The rest do not match this answer. We're going to look at some assumptions of the kinetic molecular theory before we attempt the question. So the first point we have here says that the number of molecules in the gas is usually large, and the average separation between them is large compared with their dimensions. The other assumption also says that the molecules obey Newton's law of motion. The molecules are always in a state of random motion. The molecules exert a long-range force on each other. The molecules make elastic collision on each other. The molecules of the gas are identical. If we say that molecules of the gas are identical, it means they have a uniform composition. So the word homogeneous talks about identical molecules of gases, but when we talk about the term heterogeneous, it means the molecules are not identical, they are not of the same kind, and they don't have the same composition. Let us move down to the options. This question says, which of the following is not an assumption of the kinetic theory of gases? A. The molecules obey Newton's law of motion. B. The molecules are always in a state of random motion. C. The composition of the molecules are heterogeneous. D. Elastic collision with each other. Which one is the correct option? Option C. Option C is not an assumption. Please, if you are yet to subscribe to our channel, I would like you to do us a favor by clicking on the subscription button. Thank you very much. This other question says, convert 1 kilojoules to calorie. Convert 1 kilojoules to calorie. 1 kilo represents 1000. So 1 kilo is the same thing as 1000 joules. If we are converting now from joules to calorie, we are going to divide this value 1000 by 4.2. When we do that, we get the equivalent value in calorie. Here we have 238. So the correct answer is B. This one says, which of the following heat losses is primarily not due to convection? Which of the following heat losses is primarily not due to convection? A. Boiling of water. B. Land and sea breeze. C. Circulation of air around the blast furnace. And D. Heat of the glass surface of a bulb due to current in filament. If you look at the first, the second, and the third option, they have to do with convection current, boiling of water, land and sea breeze, circulation of air around the blast furnace. So we go with the correct option, D. This one says, the two ends of a rod of length L and a uniform cross-sectional area A are kept at two temperatures T1 and T2 such that T1 is greater than T2. The rate of heat transfer, the Q over the T, through the rod in a steady state is given by, this expression is familiar, so we just pick the correct option, which is option D. Please, I want to appreciate our subscribers, and those who are still yet to subscribe, please, I would like you to click on the subscription button. Thank you, I would really appreciate that. This other question here says, a hot and a cold body are kept in vacuum separated from each other. Which of the following causes decreases in temperature of the hot body? Okay, a hot and a cold body are kept in vacuum separated from each other. Which of the following causes decrease? Which of the following causes decrease in temperature of the hot body? Okay, so if we have a hot body and a cold body, and the next moment the hot body decreases in temperature, which option do you think is correct here? A, conduction. B, radiation. C, conduction and convection. D, convection. Okay, so we pick the correct option is radiation. The heat from the sun reaches us by radiation. A hot body emits its energy by radiation. This one says, estimate the root mean square speed of the molecule of hydrogen gas at STP. Take the density of hydrogen molecule at STP to be 9 times 10 to the power minus 2 kilogram meters cube. Okay, kilogram per meters cube. So there's a negative sign here, minus 3. I take it again. Estimate the root mean square speed of the molecules of hydrogen gas at STP. Take the density of the hydrogen molecule at STP as 9 times 10 to the power minus 2 kilograms per meters cube. Let's look at the following options. We are being given the option to find the root mean square speed, V, and the density is given at STP. We should know that the pressure is also known. P equals to 1.01 times 10 to the power 5 Pascal. So with this, we can go ahead and pick an expression, a suitable expression for the example. So here we have V equals to root 3P all over the density. We substitute the value for the pressure and then the density. When we simplify that, we obtain 1840 meters per second. Let's go to the option. So the C here we have 18.40 meters per second, B 1840 meters per second. So option B is the correct answer. This one says, find the mean translational kinetic energy of oxygen molecule at 0 degrees Celsius. Given the Avogadro's number to be the value here, Na equals to 6.03 times 10 to the power 23 moles, and we have the constant here, R equals to 8.3 joules per kilogram or per Kelvin per mole. Okay, so we are to find the mean translational kinetic energy. Alright, so we pick a suitable expression, E equals to 3 over 2 RT all over NA. We substitute the given values into the expression. So we have 3 here. The R was given 8.3. The T was given, but it was in degrees Celsius, 0 degrees Celsius, and has been converted to Kelvin by adding 273. Okay, so look at the 273 here. All over 2 times, then 6.03 times 10 to the power 23, the Avogadro's number Na. When we simplify this value, we obtain this 5636.56 times 10 to the power minus 23. And then if you look at the options here in joules, we don't have the index 23, but then we can still approximate this. Look at this, convert this to standard form. We'll have 5.3. Of course, it will affect this index. Yes, so this index, which is minus 24, will reduce to minus 21. 5.64 times 10 to the power minus 21. If you check the options, you see the correct option here. Option A. Okay, so I want to appreciate you for watching. Thank you for watching. Please, I would like you to click on the subscription button. If you have not done that yet, I would really appreciate. I also want to use this avenue to thank our subscribers. Thank you very much and have a wonderful day.